All right, so determine whether each function is even or odd. I'm going to do even first. I think that's the easiest. All right, so even means that the y-axis is a mirror. All right, so that's even. Now, when it just happens in the numbers, I have to kind of look at it, and the x's should have, so I'll show you what I mean. X, x. All right, so those x's have the same, 1 and -1 have the same y values, and it looks like that for everything. All right, so that has to be even, because when the x and the x and the negative x have the same y values, it's even. All right. If I look down through here, none of the rest of them do that. All right. If you look at this one, 1 and -1 have different y values. If I look here, 1 and -1 have similar, but the sign is just different. So we'll talk about what that one means in a minute. So those two are even. Odd, when you have the graph, means if you flip the graph upside down, it looks the same. Actually, I would take your computer or whatever you're working on, flip it upside down. This first one will look exactly the same. Whoops, not even, sorry, odd. All right, so if you flip that upside down, it will look exactly the same. With the numbers, what you're looking for is for an x and a negative x to have opposite y values in terms of sign, but the number is the same. So if I go back to what I was doing here, this 1 is 4, so -1 would need to be -4. It's not. So that one's neither. Okay, and I would say probably more graphs are neither than even or odd. All right, and again, if you look here, what's going on at 1, at 2, at 3, the sign changes for the y. All right, so if 3 is 273, -3 is -273. That's what happens when it's odd. And again, if you're not sure, plot them. All right, plot them, flip it upside down, and see what happens. So there's what we've got. We've got an odd, an even for the graphs, and then an even, an odd, and a neither for the numbers.